Assalamualaikum warahmatullahi wabarakatuh. Okay, today I would like to share about our research, which is the title is Characterizations of Low-Cost Stone-Based Material Made Using Natural Aggregate and Crushed Stone. So this is our members. Okay, so the first thing first, the introductions of the research is because the high quality is required to produce a good road network. So to achieve that, we also needs a reasonable price for the construction materials. So if we refer to the figure 1, cross sections of the road, the topmost surface is the surfacings, and followed with the base course, subbase, and the last one is subgrade. So our research is focused on the base course. So in order to produce a good quality of base course and also a reasonable price, we try to do this research. So the background of this research is first, the specification demand is usually stringent in terms of the plasticity, radiation, and strength. And then the materials basically are not meet the requirement. Besides that, usually the cement, asphalt, and lime that being used are too expensive. The objective of this research is to determine the engineering characteristic of the low-cost tin-based material that made by natural aggregate and crushed stone aggregate. So basically, the materials that been used are first gumba, or a weathered sedimentary rocks, which is collected from the Nigeria, Katsina state, and also mixed with the crushed aggregates, also collected from this same area. The method that been used is by produce the blended stone material using we blend between the crushed aggregate and also natural dust in ratio 1:1 by mass, and then we follow the BS standard, ISO standard, which is sieving, particle density, portal compaction, and CBR. So this is the results. So this one is through the sieving we get the particle size distribution analysis. So from this finding, we can observe that the sample is smaller than 75 mm. This is here, and 80% of the samples are between 50 mm and also 5 mm. Okay, so according to the AASHTO, the aggregate for the stone-based material must be well graded within the grading distribution limit. Alright, so if we refer to the comparison here from the table 1, this is the current research, and the rightmost is from the specification. So all the current research obtained within the range except for the size 4.75 mm, 2.36 mm, and also 0.425 mm, which is the range is part of the range, which supposedly it's supposed to get within 25 to 55, but we get the 20. And then this one also get lesser, which is 13, and the last one also get lesser, 5. So what we can see here is the new stone-based materials meet the STO, except the 3 mentioned just now, which is quite lower. Okay, so further testing are to be performed to ascertain that this material fulfill other requirements. So we try to check upon the particle density, which is the particle density obtained is 2.67, which is from the specification, it's supposed to be within 2.5 to 2.75, so it meets the criteria. Okay, for the compaction, if we refer to this figure 5, the compaction curve, the OMC optimal moisture content obtained is 6.2%, which is the maximum dry density is 2085 kg per meter cube. So, according to the previous research, Ibrahim Abu El-Mati Bahiri in 2013, he get the range is in between 1740 to 1984, which is we get slightly higher, 2085. And then the OMC is 9.5 to 14.7, which is we get slightly lower, 6.2. This shows that these materials are better in terms of the OMC and MDD, because the samples are mostly is coarse material between 50 mm and 5 mm, which is about 80%. So that's why it, in terms of its density and porosity, improve, because it doesn't hold the moisture. Alright, so in terms of CBR, according to the figure 6, we can see that the base load and also top load is almost meet at the same path. Okay, so the CBR obtained is 82%, which is based on the AASHTO, the minimum CBR should be 80, so it meets the specification. Alhamdulillah. So, right, as the conclusion and recommendation, it can be said that Gumba and crushed stones are a good and a new material that satisfy the requirement for base course material in terms of gradation and strength, because as the base material contain 5 materials smaller than 75 mm, and about 80% of the material are between 50 mm and 5 mm. So the MDD also improve, and the moisture content, particle density, and CBR also improve. So we can say that based on the characterization, the stone base developed using the natural aggregate and crushed stone can be recommended for use for the usage of construction and as road-based course. So professionals in the construction industry are encouraged to use local accessible material in the construction to reduce project costs without compromising the quality of the work. So thank you. Hope that we can collaborate together. That's all.